Hello everyone, my dear friends, how are you all? This is your educator Ayush Jain and I am presently pursuing BE in Mechanical Engineering from IIT DAV Indore, qualified JEE Mains in 2018 and I am preparing for GATE and ESE examination. Okay, so let us just start today's lecture, which is basically again on light, and this is the part 5 of light. And in this particular video, I am going to tell you about how can you easily make the ray diagrams for the concave and the convex mirrors. Okay, so let us just begin. But before starting, you should know how can we form the ray diagrams. Okay, what are the rules for making the ray diagrams? Okay, so first the rules. What are the rules for ray diagram formation? The first rule that comes in our mind that we have studied, yes, we have studied that angle of incidence is always equals to angle of reflection. So first rule says that suppose this is a concave mirror, suppose this is a convex mirror. Okay, this is a concave mirror, this is this is a convex mirror, and where we are keeping an object, we are always keeping the object on the left hand side. Okay, we are always keeping the object on the left hand side. It may be on the right hand side also, but for the convenience, we are always keeping it on the left hand side. Okay, so this is our mirror, this is a concave mirror, this is the convex mirror, this is our principal axis. Okay, this is our principal axis, and in this case also this is our principal axis. Now the first rule, which says that the angle of incidence is always equal to angle of reflection. Suppose that this is the incident ray. Okay, this is the incident ray. Now what you have to do, you have to just do a simple thing, that is you have to draw a normal with it. Okay, suppose this is the normal. Okay, this is the normal to this particular tangent, this is the tangent, and this is the normal to this particular tangent. Now after you have drawn the normal, you have to measure this particular angle. This is let it be angle of incidence, and this angle is also equal to the angle of incidence, means the angle of incidence is also equal to the angle of reflection, and the image that you are going to get will be basically somewhere over here. Okay, you are going to get the image somewhere over here. Okay, so you can do it something like this also. This is the incident ray. We are just making the line normal to it, then the angle of reflection, and then we get the image over here. Okay, means you just have to follow the rule that angle of incidence is always equal to angle of reflection. In the second case, in the case of the convex mirror, this was for concave mirror. Okay, this was for concave mirror. And now in the case of convex mirror, what is going to happen? Let us just see. In the case of convex mirror, now suppose that this is the incident ray of light. Suppose that this is the incident ray of light. It may be at an angle. I am not making it parallel to this particular, or it may also be parallel to the principal axis. Okay, it can be at an angle. Now what will happen here also? This is what? This is the normal. You will have to make a ray something like this, which is the reflected ray, and this is the angle of incidence, this is the angle of reflection, and we all know that angle of incidence is always equal to angle of reflection. Now what will happen? See, this line, the reflected ray will not meet the principal axis at any position. Now what to do? Now you have to basically just extend this line in the backward direction. Okay, you have to just extend this line in the backward direction, and the point on which this line is meeting the principal axis, that is your image. Okay, so it is meeting at this particular point, and means this is your image. It was meeting at this particular point, this was your image. It was meeting at this particular point, this was your image. Okay, so whenever the ray of light meets the principal axis, that at that point you are going to get the image. Okay, or sometimes if this was for an object which is of a very higher size or a very minute size, but if the object is something like this, this is your what? This is your mirror. Then what you have to do? You have to just make this line. This will be the normal, and then this will be the reflected ray. You will have to make this line, this will be the normal and this will be the reflected ray. And whenever the position where these 2 points intersect, suppose they are intersecting somewhere over here, so the points at which these 2 rays intersect, this draw a line perpendicular to the principal axis to that particular point, and that will be your image formed. Okay, this is just a rough diagram, don't just take this case. Okay, so this will be basically your image formed. Okay, so if the object is of very small or minute size or of negligible size, then we are always going to get the image on the principal axis. Okay, to keep this point in mind. Now the second rule. Okay, first rule is basically angle I is equals to angle R. The second rule says that whenever a ray of light passes parallel to the principal axis, then it will also pass through the focus. Okay, means suppose this is your which mirror? This is your concave mirror. Now what is happening? This is the principal axis, this is the ray of light passing parallel to the principal axis. Then suppose here is your focus, this is your center of curvature. Then this ray of light will always pass through the focus, something like this. Okay, the ray of light parallel to the principal axis will always pass through the focus, and the vice versa is also true. Means suppose that the ray of light is that I am showing in red, this is the ray of light, it is passing through the focus, then after getting reflected, it will turn out parallel to the principal axis. Okay, it will turn out parallel to the principal axis. Okay, means you can write it something like this, that if ray of light passes parallel to principal axis, then it will always pass through focus. And vice versa is also true, vice versa. Okay, so I think this point is clear to you. Okay, suppose in the case of convex mirror, what will happen? Can we draw the image for the convex mirror also? Yes, we can draw. Suppose this is your convex mirror, and okay, this is your convex mirror, and now what I am doing, I am just covering silvering this particular part. This is your principal axis. Suppose this is the ray parallel to the principal axis. Now where is the focus in the case of convex mirror? The focus in the case of convex mirror is somewhere over here. This is your focus, this is the center of curvature. The ray of light passing parallel to the principal axis will always pass through focus, but in this case it will pass in the inward direction. Okay, it will just pass in the inward direction. Okay, and it will always pass through focus. Suppose this line, this will also always pass through focus. Okay, this thing is clear to you. The second point may be clear to you. If any doubt persists, you can always comment in the comment section, and I am going to resolve your doubt. Okay, now the third point says that suppose this is a concave mirror, suppose this is a convex mirror. Okay, I am taking both the mirrors. Now this portion is polished, this portion is also polished in this particular case. These are the polished portions. Draw a line passing through the center or passing through the pole. Okay, this is the pole, this is the pole, everywhere the point of contact of the principal axis and the mirror, this is the pole. Okay, so now in this case, suppose this is your focus, suppose this is the center of curvature, same here, this is the focus, suppose this is the center of curvature. What is happening now? Now what you are doing, your ray is just passing through the center of curvature. Let me mark it with the red pen. So the ray is passing through the center of curvature, and it touches the mirror. Okay, now what is happening? See, the ray was passing something like this, and it also turned back. Okay, it also turned back something like this. Means the ray of light passing through the center of curvature will always trace back its path. Okay, it is tracing back its path. Similarly, like this, suppose this is a ray of light which is passing through the center of curvature. It is going somewhere over here. Now it will strike the mirror and it will retrace its paths. Like I was going like this, I will again come like this. This is known as retracing of path. The same path I will it is not like that I am going in this direction and I will come in this direction. No, it is not possible. The path will be traced. Okay, now in this case, suppose this is the ray of light which is passing through the center of curvature, means it will be something like this. Okay, because the beam of light is coming from the left direction, so it is coming something like this, and it will pass it will go like this and it will retrace its path. Means the light was going like this and it will come back like this. Yes, it went inside the mirror and it retraced its path. Okay, so it will retrace its path. This is the case in these are basically the rules of image formation for concave and convex mirrors. Okay, so remembering these rules, we are going to draw the diagram, the ray diagrams for various different cases, for the concave mirror, convex mirror, and also according on just verifying those diagrams, we are going to look towards what all things that we are getting. We are going to look towards what sort of images for images being formed. Is it a real image? It is erect image, virtual image, real image, virtual image, erect image, magnified image, diminished image. What sort of image that we are getting? Okay, and also we are going to study about the properties of both the mirrors. Okay, via when we just draw the ray diagrams. Okay, so for the first case I am drawing for the concave mirror. Okay, so for concave mirror, now in the case of concave mirror, suppose this is a basic concave mirror that I am having. Okay, this is a basic concave mirror that I am having. This is your principal axis, this is your focus, this is your center of curvature. Okay, now in the first case, what we are doing, we are basically assuming the object to be present at infinity. Okay, the object is basically present at infinity. What to do in that particular case? Suppose that the object is present at infinity, we are not knowing about. It is present over here, here, in Agra, in Delhi, in Mumbai. Where it is placed, we are not knowing it. Okay, so what we have to do, we have to just draw this line which is parallel to the principal axis, and we have learned over here what, that the ray of light passing parallel to the principal axis will always pass through the focus, something like this. It will always pass through the focus. Okay, so the second rule was used. Now can we use this third rule? Can we use this? Do we know where the object is present? No, we don't know. So how can we pass it from the center of curvature? It is not possible. Yes, we can't just show it passing through the center of curvature. So what should we do? Can we use the inverse of the second rule? Means suppose that or can we just do it something like this, that suppose that this is a ray of light passing parallel to the principal axis, can we again pass it to the principal focus? Because we are not knowing about the size of the image, size of the object. Okay, we are not knowing about the size of the object, that size is this much, this much, this much, this much. What is the size? We are not knowing. Okay, so we can just draw some lines like this, and we can easily clearly see that the image is formed at focus. Yes, so in the first case, what we took, in the first case we took that the object at infinity, object is at infinity. Okay, and the image formation that is taking place, the image formed is basically at focus. Yes, image is being formed at focus only. And is it diminished? Yes, highly diminished. Okay, the image formed is basically highly diminished. Can we say about the nature of image, like is the image virtual, is the image erect? Yes, we can say, see, any of the image that is being formed in the case of concave mirror on the left hand side, that is always going to be of what sort? That is always going to be a real and inverted image. Okay, a real and inverted image. Okay, so this thing is clear to you. These are the properties and this is the position of the image formed. Now taking the second case, See, we are just moving something like this from here, then here, then here, then here, then here. Okay, we are going to take this 6 cases or 5 cases. Now, the second case that comes in our mind is that if the object is present just beyond the center of curvature. See, in the first case, it was present at infinity. In the second case, if the object is present just beyond the center of curvature, then what will happen? Okay, so I'm just drawing this particular mirror over here. This is the concave mirror. And now, this is the principal axis, this is the focus, this is the center of curvature. The object is present somewhere over here. Yes, we can measure its length. I know that the object is present over here, 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 or somewhere else. Okay, I know the position of the object present. In this case, we were not knowing the position of the object present, neither we were knowing about the size of the object. The size of the object that was present. Okay, so what will happen in the first case? What we are going to do? First, let me write over here object beyond C. Okay, so what we are going to do? We are just mark a ray parallel to the principal axis. Okay, this is the ray which is parallel to the principal axis. What will happen? It will always pass through the focus. Okay, so it is passing the focus, something like this. Now, can we use this third rule? Yes, we can use this third rule. How? See, the ray of light passes through the center of curvature. So the ray of light just passes through the center of curvature and it is just retracing its path. Means the image that we are getting is something like this. Is the image that we are getting something like this? Yes, the image is something like this. Let the object be AB. Then the image that we are getting is basically A dash B dash. Okay, this is the image being formed. Means the image is formed. Where is the image formed? Image is formed between C and F. Okay, means the center of curvature and the principal focus. Okay, so image formed between C and F. You can write it over here. And the image formed is basically diminished. We can say yes, image is just diminished. The size of the image as compared to the original image is smaller, diminished, and the image formed is basically real and inverted. Okay, so I think that this point is clear to you. Now coming to the third point. Okay, coming to the third point. See, we kept the image object over here. We kept the object beyond C. Can we place the object at C? Yes, the third case is that only. In the third case, what we are doing? We are placing the object at C. Okay, we are just placing the object at C. Now what will happen? Let us just see. Okay, this is also C and let us also just see. This is our principal axis. This is, suppose this is the focus. Suppose this is the center of curvature. Now, where we are placing the object is placed over here. This is the object that is present. Let us name this object as A and AB. Okay, this object is named as AB. Now, second rule, what is it? The ray of light passing parallel to the principal axis will always pass to the focus. Okay, so this was the ray of light passing parallel to the principal axis and it just passed to the focus. Can we just use in vice versa? Means that suppose that this ray is passing to the focus, can I just make it parallel to the principal axis? Yes, this is also possible. Means the image that I am basically getting is where? The image formed is over here. And we can easily see that the image is real and inverted. Image is size. What is the size of the image? This image is basically A dash B dash. And the size of the images that we are getting is basically same. Yes, the image formed is basically of the same size. Okay, so image formed is at center of curvature. Yes, the image formed is image at center of curvature, and the image formed is of same size. Okay, this image formed is of same size, and also this image formed is basically real and inverted image. Okay, this is a real and inverted image. Okay, so this diagram is clear to you, I think. Now comes the fourth diagram of the day. Yes, when the object is present, now we are just moving towards this side, means the object is present between C and F, okay, between the center of curvature and the focus. Object between center of curvature and focus. Okay, let us just look towards this case. Now again I am drawing the same mirror. Okay, this is the same concave mirror that I am having, and okay, this is the principal axis. This you just mark the poles also, okay, because it is useful sometimes, so just mark these poles also. Now this is our focus and this is the center of curvature. The object is present between the center of curvature and the focus, means object is present somewhere over here. Suppose this is the object that is present. What will happen? Again the same things, What? The ray of light will pass parallel to the principal axis. This ray of light after touching a mirror will pass to the focus, and let us consider the case of center of curvature. What will happen? Can I just draw it something like this? Okay, means the image that I am going to get is going to be something like this. Okay, this is the image that is formed. This you can name it as AB, and this is B dash A dash. Okay, now here the what sort of image are we getting? Okay, first of all the image is present beyond C. Okay, image beyond C. Okay, now the next thing, the image formed is of same size? No. Diminished? No. Magnified? Yes. In this case, what we are getting? We are getting a magnified image. Okay, the image formed is basically a magnified image, and it is real and inverted image also. Okay, it is real and inverted image also. Now, considering the fifth case, can I write it over here? Yes, I think there is sufficient space, so I can write it over here. The fifth case tells us that if the object is present, just move somewhat this side. Yes, I am coming to focus. So if the object is present at focus, okay, if the object is present at focus, then what sort of image will be formed? Okay, then what sort of image will be formed? So in this case, what you have to do? In this case, again, just draw this similar mirror, which is basically the concave mirror. Okay, this is the principal axis. Suppose this is the focus, suppose this is the center of curvature. Now in this case, okay, in this case, what will happen? This is your, what is this? This is your object, and the ray of light will pass parallel to the principal axis. Okay, this ray of light will pass parallel to the principal axis, and after touching the mirror, it will just turn out something like this, and it will always pass to the focus. Now after that, can I make a ray of light passing to center of curvature? Yes, I can make. See, this is the ray of light which is passing. It is passing to center of curvature, and where are they going to meet? I can't make it. Yes, I can't see them meeting. Means these rays of light are parallel. These reflected rays are parallel. Yes, these may be parallel. Means the image that we are going to get is going to be at infinity. Okay, the image that we are going to get is at infinity. So, and what is the size of the image? Yes, we can see that the size of the image, if the image is formed somewhere over here, the size of the image will be something like this. Means it is highly magnified image. Okay, so first property, image is formed at infinity. Yes, we know that image is formed at infinity, and it is a magnified image. Yes, okay, this image is a magnified image, and also because it is formed on the left hand side of this particular mirror, then we can say what? We can easily say that the image formed is basically real and inverted image. Okay, so the image formed is real and inverted image. Now one more case. Yes, we are having one more case. What is that case? That case tells us, see, we are just we started our journey from here. then we came here, then we came at center of curvature, then we came between center of curvature and focus, then we came at focus. Now can we come in between pole and focus? Yes, we can come. See, the sixth image is the object between pole and focus. Okay, so again drawing this particular mirror over here, and this is the principal axis basically. See, is the diagram clear? Okay, I can make it clear. This is the principal axis, and suppose that this is your focus, this is your center of curvature, and the object is somewhere over here. Now what will happen? If the object is in between focus and the pole, this is the pole and this is the focus, what will happen now? Again, you have to draw the same diagram, something of the similar sort. This line will pass parallel to the principal axis, this will pass to the focus, and it will move somewhere over here. This ray of light will pass to the center of curvature, it will go something like this, but we can easily see that they are going to diverge. Okay, they are just diverging. Means if we just backlash their path, means if I just extend this part on behind, then will I get a meeting point? Yes, I am going to get an imaginary meeting point, and that's where the image is being formed. Okay, because this is a meeting point, the image is formed somewhere over here. This is the image formed. Let it be AB, and this be A dash B dash. A dash B dash is the image formed. Now, can you tell about the nature of the image? Can you tell about the nature of the image? Image formed is, can I say it is behind pole? Okay, the image formed is basically behind pole. Okay, it is behind pole, no problem in that. And image formed is basically highly magnified. No, not highly magnified, but I can just say it magnified. In this case, you can introduce this word highly. But in this case, I can simply say it as a magnified image. Okay, this is basically a magnified image. Can I say that the image is real inverted? Oh God, no, the image is not real inverted. Image that is formed on the left side of the mirror is real inverted, but image formed on the right side of the mirror is basically virtual. Okay, this is basically a virtual image, and it is what? Virtual image, and see, it is not inverted. Yes, virtual and erect image. Okay, so in this case we are going to get a magnified virtual erect image which is formed behind pole. Okay, so let us first come to the properties of the image form, uses of a concave mirror. Okay, can we see the uses of concave mirror? See, this real inverted cases are not for us. Okay, what we have to do with the real image? When the image is not getting formed, when the image can be produced on a screen, what to do with that? But what we need is a virtual image. Okay, we just need a virtual image. Means all these cases are not useful for us, but this case, only this case is useful for us. See, image being formed is basically magnified, virtual and erect. Have you seen your a lamp at your house? Okay, you might have seen the lamp is something like this, and what is happening? The lights are spreading. Okay, so in the lamps, what we use in lamps, uses of concave mirror. I am writing over here, uses concave mirror. First use in a magnifier. Yes, a magnifier, because it produces a magnified virtual and erect image. A magnifier is made up of concave mirror. Okay, so a magnifier. Anything else? Magnifier. Your fathers might be shaving regularly or doing certain stuff, or the barber may use his comb to just chop your hair. Okay, so what is that? That is also concave mirror. So in shaving, okay, as shaving mirrors, you can write it like this, in shaving mirrors. Anything else? Anything else? Anything else? Yes, there are various things. See, the bulb that is lighting over our head, that is also a magnifying, that is also a concave mirror. Okay, so in bulbs, to produce light with more intensity. Okay, bulb. Anything else? Anything else? I think that these are sufficient. But you can also use it in solar panels. Solar panels. So there are very vast uses of a concave mirror. The doctors, yes, the most important case, the doctor used to examine our teeth, our eyes, or any other body part. So it is used by doctors also. Okay, by doctors. So these are basically the uses of a concave mirror. Now we are moving towards the image formation of a convex mirror. Do we have to make these many number of images again? No, only 2 images. Yes, you just have to make only 2 images for the case of convex mirror. What are they? When the object is present somewhere over here and when the object is present at infinity. Yes, only these 2. Because in the case of convex mirror, the focus and the center of curvature are present on the right hand side, and the light is coming from the left hand side. So where will you mark the focus focus in this side? Where will you mark the center of curvature? It is not possible. Okay, so in the case of convex mirror, the first case that we are taking place that we are taking is kahin bhi. Okay, kahin bhi. Okay, now what is happening in this case? Suppose this is a convex mirror. Okay, this is your convex mirror. This is the principal axis, this is the focus, this is the center of curvature. Now the ray of light is coming from anywhere. Okay, let it be over here. Okay, this is your object. This is your object. Let this object be AB. This is the object AB. Now what you have to do? You have to just mark a ray of light which is passing parallel to the principal axis. So this is the ray of light. I think I have made it at a certain distance, but no problem, we are going to get the same image everywhere. Okay, so this is the ray of light passing parallel to the principal axis, and it will always pass through the focus. It is always passing through the focus. And now the second ray, what we have to do? We have to make it such that it passes through the center of curvature. Okay, so this ray of light is passing through the center of curvature. Assume that it is passing through the center of curvature. Where are we getting the image? We are getting the image between pole and focus. Okay, we are I think I made certain mistake. No. One second. Yes, this is the image formed. Okay, image formed will be, in any case, suppose if you just move it over here, image will always be formed between pole and focus. Between pole and focus. Okay, I think this point is clear to you. And the image that is going to be formed will always be a diminished image. Okay, it will always be a diminished image. Okay, so I think you might be clear with this case, and the image formed will be virtually direct. Yes, because no, the image here which is being formed will be what? Will be real and inverted image. Okay, image. Sorry, one second. Yes, it will be a virtual direct image. Okay, so this point is also clear to you. Now after this, the second case comes when this is a simple case, I need not mention it also. When the object is present at infinity, it will pass over here, it will pass over here, it will pass over here, it will pass over here. The image will be formed at focus. So when object at infinity, it will what? It will pass through focus. Image will be formed at focus. Okay, and the image will be highly diminished. Okay, image will be highly diminished, and that's all. Okay, so guys, Yes, the uses of the convex mirror. Where are the convex mirror used? So convex mirrors are basically used in the case of vehicles. Okay, convex mirrors are basically used in vehicles. One second, this is real and inverted image. Just one second. What I have done, this is going to be virtual erect image only. Okay, let me draw a clearer image so that you can distinguish it. Yes, this will be the image form, and this will be a virtual erect image only. Okay, so it is used basically in the case of vehicles. Okay, in the case of vehicles as a rear view mirror, because when the ambulance, suppose this is the ambulance that is in front of you. Okay, now you are just looking towards the mirror. You will not be able to see that whether ambulance is coming, whether the bike is coming, whether the bicycle is coming, whether the car is coming. You will not be able to see. But with the help of this convex mirror, the image gets diminished. Okay, we are using this, which case where the image gets diminished. So because the image in the rear view mirror gets diminished, you are very easily able to judge that which vehicle is coming, and according to it you can provide them the space. Okay, so in the vehicles they are used as a rear view mirror, Now suppose if the interviewer asked, or if in your examination it comes that suppose that you have to just differentiate between concave mirror, plane mirror and convex mirror by not touching at them, but by just viewing your face over them. How can you do it? Yes, you can do it, because a concave mirror, if a concave mirror is producing a virtual image, then that image is always going to be of a magnified size. Okay, that image is always going to be of the size greater than the original size, and in the case of plane mirror the image is going to be of the same size. In the case of convex mirror, the image is going to be of a smaller size. Okay, so these three are on the basis of these three differences you can judge whether you are using a concave mirror, whether you are using a plane mirror, whether you are using a convex mirror, and many other things. Okay, so I think that this lecture was quite long, but hope you enjoyed this particular lecture, and let us meet soon. Please do like, share, subscribe to my channel, press the bell icon, and take care. See ya. Bye bye.